So the idea is that we can change probabilities to try to achieve this. As I mentioned earlier, we saw in the utility chapter that if the real world had probabilities p, by changing the probabilities to p star, risk-averse investors could act as if they were risk-neutral by using p star instead of acting as if they're risk-averse using p. And so the question becomes, is there a way of shifting the probabilities from p, which were the correct probabilities of events in the real world where alpha existed, to a new probability structure? Said another way, if we start with a z that's normally distributed, that was our original Brownian motion, and we define a z star to be that original z with a drift. So we've now stuck a drift onto our original Brownian motion. Is there a normal distribution under which z star, and you can see there's a little bit of typo here, this should be a z star, under which z star has a mean of 0 and a variance of t? In other words, we can see that under the z probabilities that the mean of z star is in fact a drift term. And the question is there some way of shifting probabilities so that I shift the mean of z star back to 0? The variance is okay. You can double check that the variance of z star is already t. I don't have to worry about the variance. I've got that in order. The variance of z star is already t. But is there some way of changing probabilities on the path so I can shift the mean down from its current value, which is the Sharpe ratio times t, down to the value I'm looking for, which is 0? There's a theorem in stochastic process theory called Gersonov's theorem. And it turns out the answer is yes. Gersonov's theorem says that under certain conditions, one is able to change the probability structure so that these drifted processors can be forced back into basic plain vanilla Brownian motion. And in this particular case, we can actually identify the probability distribution that does it. Namely, that if I use the probability distribution of a normal distribution that has a negative Sharpe ratio mean and a variance of t, under this probability distribution, the mean of z star gets shifted to 0. Because what in effect is happening is that the mean in the PDF I'm using subtracts away the drift of the mean of the z star that I started with. So here's a case where you can actually identify the probability distribution that does it, and namely, Gersonov says just use the probability distribution of this shifted normal, and this will automatically shift you back to the mean of 0. Of course, it's normally distributed. We didn't change the variance, and we're all set. And this is the essence of risk-neutral pricing. It's that we can change the drift in the process by, in effect, moving a piece of the drift into the dz term. And then by changing probabilities, in effect going from p to p star, going from a standard normal distribution to a normal distribution with a non-zero mean. By changing that distribution of prices, we can then convert that dz star into ordinary Brownian motion. And just as if it were always original Brownian motion, we just change the probabilities.